just to restart. So, Defin, episode 3. Here we go.
Hello, Ray. How are you?
I'm good. Yeah.
Okay.
Like you say, hello, Ray. Ray McDermott here from Belgium.
This is Vijay from Holland, and we just wanted to make sure that we introduce ourselves a bit so people don't forget us already.
And just a quick reminder that we're doing this podcast to try and give people a deeper technical understanding about Clojure and ClojureScript. Hopefully, still keep it fairly accessible. But I think we've had some pretty good support and follow-up from the listeners. It's been pretty positive. In fact, remarkably positive, even on places like Reddit.
Yeah. I mean, I'm actually really surprised, and it was pretty amazing. And as you were pointing out, there was before even we announced it that a new episode is available, somebody else already tweeted following the SoundCloud upload. So we are very happy with the feedback that we've got so far, and we hope to keep the level up and then help you guys. I don't know whether you're listening while you're doing your workout or going to your work. We want to make sure that you get some Clojure knowledge.
Exactly. Yeah, actually, the other thing we should do is make a shout out. We've got a website on Defin Audio. We're also on the Twitters. You can find email on there as well. If you want to get in touch with us to tell about conferences or meetups or other things that are happening in the Clojure sphere, we're in Europe, but anywhere in the world, really, this is a global thing. So we will tell a bit about European things, I guess, with as things get a bit more exciting in Europe, round about October when we get the Euro Clojure bandwagon rolling into Bratislava. I've booked my airplane tickets, by the way, for that.
Oh, okay. I was planning to do a road trip there, so I'll probably drive.
Oh, you're making a road trip?
Yeah, all the way from the Netherlands to Slovakia, I think, is it? Slovenia.
Slovakia.
Oh,
Slovakia, yeah. Bratislava, yeah.
Yeah, that's going to be a pretty long road trip, but I hope to have some maybe nice company during that time, and then we can talk stuff. Or maybe we'll do a podcast on the road. Okay.
All right, good.
Let's get into this episode. I think last episode we discussed a lot about the reader, and we promised that we're going to get into REPL. And I also, I think, made a nice tweet, or I was piquing some people's interest that we are going to have a pretty good episode with a surprise for you guys and girls. So let me introduce our special guest for this episode, and he's been very kind to respond to our request, and then as you probably know him, or the Clojure people already know him, I think. So he's been the primary developer for Plank to bring ClojureScript to the Mac, and also the Replete. So you guys are, I think Ray was showing off Replete on his iPad Pro, and so I'd like to introduce Mike Fikes. Hello, Mike.
Hi, Ray. Hi, Vijay. How you doing?
Good. How are you?
Yeah.
Really good.
Thank you for joining across the pond.
Oh, no problem.
All the way.
Yeah.
So
it's an honor.
I think first of all we'd like to do a quick introduction. So can you tell us something about your interest in Clojure, and how did you start into building these kind of REPLs? And you're contributing a lot especially for the Mac and iOS platform. So how did you start?
Yeah, so I would say that I was probably like someone who wanted to do functional programming maybe about 5 years ago, and I went down the path of learning about Haskell and Scala. I didn't really get into Clojure back then, but later on I was developing iOS apps, and I kind of had the freedom to do whatever I wanted to do because I was doing it for myself, and ultimately decided to try doing it using ClojureScript. And that's what kind of got me into the Clojure ecosystem and the language. I think that was maybe a couple years ago. To do that, you kind of want to have a REPL into your device. So that was kind of like always this dream of mine, is to be able to have a REPL into my iPhone.
Yeah, because I mean, one of the things that I was really surprised about this whole Apple ecosystem is that there was no other language runtimes were allowed onto the App Store before. and then Replete
That's true, yeah.
Yeah, and then later they started allowing, okay, you can use JavaScript, and then I think that kind of paved the way to making this Replete application.
Yeah, I was kind of worried about that as well. And I had like a conventional app even prior to that that had ClojureScript inside of it running it. And I was, it's you can't even tell that it's in there if you didn't know. But I was kind of like wondering, like, well, Apple might know, But you're right. Later on, I think they actually formally blessed that way of doing apps.
Yeah.
They had even a session in one of their WWDC conferences where they talked about how to use JavaScript to drive an iOS app. So it's definitely a blessed way of doing it.
Yeah.
I guess the only thing that's a bit weird about the JavaScript on iOS, though, is this whole thing that's going on in the ecosystem about circumventing the update process.
Yes, yeah. So the reviews take I guess they're getting quicker now, but they used to take about a week at least to get through a review. So you have this motivation to want to try to avoid that if you can. And I think Apple really just doesn't want you to, fundamentally change the behavior of your app without it really going through review. But you're right. If you can just have almost like a backdoor or a new way to put some JavaScript in there, you can update things. And
okay.
That's kind of yeah.
So to set up some sort of an kind of a vague agenda for this episode. So first we'd like to discuss some the internals of REPL a bit. Of course, Mike will be helping us, and we'll be asking questions to Mike, and maybe we are going to interview Mike and then give him a job as a REPL author, or at least Mac expert, and later we'll get into a bit more into the integration of the REPL and the IDEs, and I think Ray was pointing out some other uses of REPL as well.
So I think we want to look at there's various different classes of REPLs, isn't there? There's REPLs which are kind of like stuff that's for specific platforms, stuff that's inside of IDEs, stuff that's like listening on the file system for live coding experiences, and then stuff that's on the web, so you can have embedded ClojureScript in your web pages, and then there's all these kind of fun things that we maybe come to at the end a little bit, like live REPLs, live music, REPL as a kind of art form. So yeah, okay. Maybe as we start, Mike, with your tech job interview day one, where me and VJ will just troll the shit out of you about. So, Mike, what do you know about ClojureScript then? Anyway, Vijay, I'll let you go first.
Okay, sure. So we have been checking your GitHub, and we noticed.
Okay.
Anyway, so let's talk about REPL. So, Mike, can you tell us a little bit about how a REPL works from a tooling point of view, and how REPL reads and gets the forms and gives you the output?
Yeah. So I guess if normally you have to type something into a computer, right? And it has to read your characters. And then at some point, something in that stack gets this stream of bytes, or, a string basically. And that's, I suppose if you have a REPL that's written in Java, you're using Java to get that, through some sort of input mechanism. Something like Plonk or Replete, they're using native ways to get that. But ultimately, I guess in the end, you're just getting a string that's passed to you, and you can get it whatever way you'd like, when you're building that REPL. And then of course you have to take that string and pass it to the reader, like your last episode was talking about. Yeah. And you can convert that into a form. And what I think is kind of interesting is in something like Clojure, you can then have that form be compiled. And what's interesting in ClojureScript, you kind of have to you're transpiling it, right? You're turning it into JavaScript.
Yeah.
And one thing that's kind of interesting about, if you think about conventional ClojureScript REPLs, where the JavaScript engine is actually running off in a browser in the typical case. And what's
that's basically kind of a piggybacking into the browser REPL.
Yeah, so in that case,
the browser REPL.
Yeah, in that case, really one fundamental setup is that you have a Java process that is your REPL running on your computer, and then you have your browser sitting there with the JavaScript engine running in it. And effectively inside the Java process, you're using the Clojure script compiler, which is written in Clojure, to compile down to JavaScript forms. And really, it's not that complicated. But what happens is once you have the JavaScript, you send it across the wire or whatever, some way to get it into that remote JavaScript engine, and you evaluate it in there as JavaScript.
Okay.
And that kind of mutates your JavaScript environment, usually making a new function or maybe defing a new value, something like that.
Yeah. So the fundamental difference between Clojure REPL and Clojure script REPL, as you were pointing out, is the way the compilation step essentially in case of Clojure. And there is no compilation step there is compilation, but that's basically transpiling into JavaScript.
Yes. Yep.
Okay.
Yeah. And apart from that, I guess it's roughly the same model. Yeah.
Okay. So Mike, what about the kind of traditional REPLs that are terminal-based, like Planck, or stuff that's based over the network, like NREPL or socket REPLs? What do you think about the differences there?
Okay, yeah.
In terms of the implementations.
So I guess one, you mentioned socket REPLs and NREPL. I guess you could draw a distinction between REPLs that have their environment with them. Like Planck is an example of that, and Replete is an example of that. Since they're based on Bootstrap ClojureScript, they're kind of closer to Clojure, and the fact that the underlying host, if you will, that we always talk about, these are hosted languages. The host is there with you in the REPL, and when you have something like like Ambly that's talking to a remote iOS device, or a traditional REPL that's talking to a web browser, those are the cases where you have something that's remote. But then if you think about socket REPL, that just lets you use even like Clojure or ClojureScript REPLs. You can use those across the wire. So in that case, you are remote, but the REPL, if you will, is kind of itself remote from you. You're just basically telnetted into it and sending characters to it across the wire.
Yeah. I think you were also mentioning the kind of, so what is the communication medium? So in a normal socket REPL is essentially bytes, right?
Yeah. So socket REPL is remarkably simple. It's basically, you can imagine if you had a normal REPL, and this is exactly the way Planck works, and I'm assuming the Clojure socket REPL works, is you basically inside your REPL, say you have a REPL that's working like Planck was, and then I said, let me add socket REPL support to it. All you do is you open up a socket and listen. And as those bytes come in, it's almost as if it's the same as if the user had typed that into the console. You take those bytes and you almost treat them in the same way, and you evaluate them, and then you send you kind of like print the response back across the REPL, across that socket.
Okay. So in the case of NREPL, I think it's much more structured, or there is a protocol or some sort of a schema behind it, like what kind of data that is flowing on the network. I
think you're right. Yeah, there is some sort of. I haven't dealt with it, but there's something more to it. Yeah.
Okay.
Yeah. So it's based on maps, isn't it? All the data is sent across in maps rather than as in raw bytes.
Yeah.
Okay. So I was curious about the naming though. So I can understand Replete. Replete is based on REPL, so there is some sense of I don't know how did you come up with the name, but why did you pick Planck? I mean, is it Planck's constant, like Max Planck?
Yeah. Okay. So I was messing around with Replete, and I was thinking, Replete is a bootstrapped REPL, and I was using it, and it was pretty quick to start up even on an iPhone. I'm like, I can actually start it up, and within a second or two start typing forms into it. So I'm like, what if I took this thing and I put it on the desktop? It'll be even faster, right? So that's what I'm like, I'll put it on there and I'll see how quick I can get this thing to start up. And I'm like, what is the fastest thing you could think of? And that's
Planck's.
It's that Planck time length or whatever. That's where the name came from. I'm like, maybe I'll just make a play on that. Yeah.
Oh, pretty cool. So someday it's going to be super fast that we'll probably start to travel back in time, essentially.
Yeah. It'll anticipate what you're going to type in and evaluate the form before you type it.
You've got some AI work to do on that one. Yeah.
Okay, so can you give us some idea about the kind of technical underpinnings or technical details about the REPLs that you have. So I heard from Ray that you were using WebDAV or something to get the REPLs working on iPhone in the beginning. On iOS essentially. So what is it based on right now? So how does it work?
Okay, so that's Ambly that Ray was referring to. And the technical thing about that one is that if you think about you're using a Clojure script REPL normally, what it'll do is as it compiles or transpiles your files or your code to JavaScript, those get written to disk. And the way they really work is then that stuff can be loaded into your JavaScript environment. The only real difference with Ambly is that the JavaScript core engine is remote. It's on a remote device. And actually, David Nolan came up with this architecture, which is to say, hey, what if we, instead of having the compiler output be written to disk on your Mac, essentially, what if we redirect it to point it at the device and write to a file system on the device? And that's roughly, if you kind of like really summarize what Ambly's doing, is it's basically compiling to the device as a disk. And then there's a little bit of like coordination above that to say, hey, after you've compiled this file, go ahead and tell the remote JavaScript engine to load that file in, load the resulting JavaScript in.
Okay, but how do you contrast it with Plunk and
okay,
Replete?
yeah. So Plunk and Replete have an easier job because they are kind of co-located with the JavaScript engine. So in that case, it's as simple as basically saying, okay, the user typed in a form, let me compile it, transpile it to JavaScript, and evaluate it right there in the same environment. There's no need to deal with, tossing it across the wire to a remote entity.
Just another thing, following up from that, Mike, actually, does that mean that with Ambly, you don't need React Native?
That's true. Yeah. So I've used Ambly to just develop straight up apps where you have a Clojure script environment running in the app, and actually Ambly was created before React Native existed. Yeah. So you're right. Exactly.
Interesting. Yeah. Because obviously React Native is mostly about making the UI more performant anyway, isn't it? Rather than actually having the underlying JavaScript engine itself, because that does come with iOS, like you were saying earlier. Mm-hmm. So it's just a matter of making the UI nicer and smoother and more responsive on Android and iOS.
Yeah, and I think for at least for me, the whole draw of React Native. So I wrote a Clojure script app in the App Store, and I don't know if I would do that again now that React Native exists. Because what I did was I basically, like I said, I have this dream of writing stuff in a functional way, pure functions, immutable data. And that previous app was built by having Clojure script, if you will, drive and poke at the native UI elements. What else are you going to do? You have to kind of do it somehow. And it's this big bag of mutation, right? And
right.
And now for me, the important thing for me, at least with React Native, is the ability to use things like OM and reagent and take a more structured approach to things and deal with things in a more functional manner. Your UI is a function of your state kind of argument.
Yeah. So I see that I've been trying out Replete on iOS, obviously. And of course, I miss Emacs because, Replete has this tiny text area.
Oh, man,
and it's very difficult to type.
I apologize. I apologize how hard it is to type on there.
No. It's already awesome. And we see that, the way that you're building features into it. For example, you just introduced the parent for support, I think, pretty recently. So what was it? Is parent for completely implemented in Clojure script on Replete?
Oh, okay.
How did you do that?
So parinfer was originally implemented in Clojure script, and then Sean LeBron, I think, optimized it, and he took his original implementation and converted it to a pure JavaScript implementation. I think he was really focused on performance for handling cases when you have a lot of text that you're editing.
Yeah.
But yeah, I guess you were asking how does that fit into Replete? It's really just a library that it uses. So as you're typing forms, and it's actually only using that. It's only using parinfer to decide how to format the text as you're hitting return, if you will. Like when you want to go to the next line, it's not really a full paren for implementation. So it's kind of like formatting.
I thought when you opened a parenthesis, up a parenthesis, it did pop another one afterwards.
Oh, you're right. Yep. Nope. I've forgotten about that. You're right. It does do that. Yeah.
It inferred a parenthesis, perhaps.
Yeah. Hence the name. Yeah.
Come on, Mike. Come on.
Thank you.
But if you really want to get this job,
someone failed the job interview.
But do you plan to make it like a full editor eventually? Because I would really love to have that on the device, so I can. I know opening files and all the stuff is pretty difficult on macOS. I know that. And I have some editors installed on that one, but they get the data from Dropbox or some other places.
Yeah. So for me, Replete was all about. I don't know if this is common amongst people, but when I was learning Clojure, I would walk around and think about it, right? And I'm like, oh, how does this form? How does that form work? How does binding work? All these concepts that you're new to, and to be honest, it's kind of geeky. I would want to just try it out. You will think about something, you want to try it on a REPL, and sometimes you're not at a computer. So my dream was really just to have a simple REPL that I had with me in my phone to try little short form things on, and I think it's good for the educational or learning phase. But some people like to actually take their iPad on a train or something like that and try to edit some code and use something like Replete to do that. So I think better editing support in it would be great.
Yeah, that's true. I think it will be amazing because you were pointing out people using it on the train, but you're just putting Clojure script or experimentable Clojure implementation on an iPhone essentially means that there is a huge next generation of people sitting in the toilet actually typing Clojure forms instead of reading Reddit.
Oh yeah.
So there is this. Everybody uses phones.
It's a nice image.
Right?
Yeah.
But it is spectacularly useful, I must say. I mean, that's what I use it for. I just open the phone and I have Replete, and then I just type in, let me try this protocol thing, and I just start typing it in there. So that was really fun.
Yeah. I still even use it today. If you're for example, syntax quote, you're like, how does
Exactly.
I mean, my God, you really have to type those things out and just try them, and it'll bug you if you don't. Yeah. So and the main thing I would like to somehow add to Replete is perhaps a better keyboard. That's has some parentheses on it or something like that. But that's evidently hard to do. So.
Because I'm using the prompt application by the Panic guys, the SSH.
I've used that one as well. Yeah,
and they have pretty amazing keyboard there. Of course, because the whole parenthesis you can customize it. I was curious how difficult that is. Maybe I should try that out because I did try some macOS, the iOS development some time ago. So maybe I can look into it.
Yeah.
But if there is a right keyboard, like the Lisp keyboard, I don't know if you're following the Planet Clojure thing, because there is one person who is now on the quest for building the best Lisp keyboard ever.
Oh yeah?
And maybe we should just take that layout and then try to get that one in. Anyway, I'm not trying to push more issues into your GitHub. I'm just floating some ideas around.
Well,
I think the concept of putting an ID around a REPL is definitely something we'll talk about a bit later.
Yeah.
But I think it's it's a lot of hard work, that's for sure, and it's a different task, as you say, Mike. It's something which the ID has to do a hell of a lot more, interact with GitHub or various other things. Has to have a whole visual flow, saving files, and there's a lot more stuff around it, making projects, integrating with all kinds of other tools. So I don't know. I think we don't want to put too much on Mike here,
Yeah.
Well, I would also say it's Replete and Plonk are both open source. So if you want to contribute,
exactly,
have at it.
That's true.
Awesome call there. Yeah. Well, actually, we're just waiting for VJ's pull request on Clojure from last week. He's going to make all kinds of good things happen.
Yeah.
Just actually, before we sort of finish up. There was a little chat going on around. I think it's mostly initially instigated by Colin Fleming and his talk at the Conj recently. Not this one. Or was it this one? Was it Clojure West? I can't remember. It was the Conj, wasn't it? some conference in America. And he talked about how we could do better with error messages, and he's definitely trying to do that with cursive. And then Bruce Howman is starting to do this stuff with configuration files around Figwheel, and I know you're interested in it as well. Could you maybe give us something? What's your feeling around that area? What kind of stuff could we? What do you think about that, and where do you think we're heading?
So if you look at like the history of ClojureScript itself, even just going back like a year ago, the underlying, like the ClojureScript language itself, the implementation was solid. Like you could rely on it to work, but the tooling and all the stuff surrounding that was harsh or difficult, and still is in many ways. But I think with enough effort, the community has kind of polished enough of things, and we've gotten to a point now where ClojureScript itself it seems like it's turning a corner now, where people are starting to focus on the nice, the developer experience on top of all of it. So that, when you do get an exception or whatever, it kind of shows you where in the code the exception occurred, or tries to point to you, or, this, like the gravy on top of things is starting to occur now. That's my general high level take on all of it.
But I think that's a really good way of looking at it. But it's one of the biggest complaints about on the Clojure surveys, that people complain about exception messages and stack traces and error messages. And people, I think one of the things that I heard on the Cognicast last time when Rich was talking about spec was that actually with the macros, you will be able to put some of this spec magic inside of there to improve the transformations and actually understand where the transformations fail and give better messages. So it seems like some of the underpinnings is getting better as well. Some of the underpinnings, because I think Colin was mostly talking about Clojure, not ClojureScript. So it's definitely across all of these environments.
Yeah, and one thing I've kind of seen with spec is you can actually you can spec a macro, if you will. You can define what the macro takes, and one way of looking at what you get out of that is that you can detect a failure to conform right away. Like before, like during macro or right before macro expansion. So instead of like this train wreck occurring later on after macro expansion, and you call something way later, and it's you kind of get this upfront thing occurring with spec with macros, and I think that could help a lot.
I'll be really interested to see whether with 1.9, because actually originally when I heard about spec, I thought, it's just going to be one of these core async things. It's just going to be another library. And it sort of feels like it is a library. But then when you start thinking about it a bit further, you think, maybe it does need to be in the language. Because obviously they're very conservative with changing the language itself. But if it's in the language, then in theory, they could reverse engineer some of these macros and put specs around them and actually give better error messages. I don't know if they're going to do that, but in theory, that's possible. Yeah.
So I was messing around. You can try this yourself. Like if you said, I want to write a spec for defen, which is the name of this podcast, right? So you can write a spec for that.
It's basically valid, awesome, and then it's true.
Yes. But you could, if you look at that macro and the way it really works.
Oh, the egos.
There's like a lot of steps inside that macro where it's looking to see like, okay, is this the doc string? Is this the attribute map? Is this the arguments vector, the parameter vector? And you look at the way all that's done, it's kind of like hand coded. Look, it's pulling it apart, and figuring out which pieces are which. And with spec, you have like this cat abstraction where you can say like this thing follows that thing. It's a regular expression idea, right? And you can I guess what I'm trying to say is you can, as a human being, you can quickly write the spec for defen, and you can say this occurs before that thing. And what you get is this wonderful machinery underneath it that will take your spec and see if what the user typed in conforms to that. So it makes it humanly possible to actually just write specs for macros. Even if you or I were writing a macro, we could actually write a spec for it and produce a better result.
Yeah, definitely. I'm just saying that if they were to sort of do the work on the language as well, then you'd get it everywhere. Because obviously, I don't want to write a spec for Defen.
Oh yeah,
mental, I think.
that's a good. I think that there. Oh, I hope that there's a plan for Cognitect or the community to write specs for everything in there. Yeah.
Yeah.
That's basically
All
like
right.
like the core type thing, or in the Racket community there is this retrofitting the whole contracts onto the existing libraries. So there is a lot of. I think that it's a Spartan effort. There is a lot of time and effort required to do that for the entire Clojure core, though.
But you could do it on. You could do it on the like Defen and
piece by piece basis. That's true.
Some of the most core macros.
Yeah.
But I guess it'd be an interesting question actually about whether spec actually reveals some behavior that is kind of like would break things.
Yes,
well, I'm just thinking if you put the spec in there, suddenly it won't pass. Things that have passed before suddenly won't pass anymore. So I don't know. I guess there's all these kind of, because obviously that's the backward compatibility thing is an issue. So
yeah.
But they're actually, if I'm not wrong, you could set it up. Don't say this. Okay, I'm going to say this. A bit like Scala, where it's all optional, Okay, should forget that. I'll edit that out. Everything is optional.
Well, everything is an underscore. That's Scala.
Ouch.
Let's not get there. So coming back to the whole Planck thing. So can we use Planck to write native scripts or something on Mac? Because this has been one of the biggest complaints from people, or not complaints, but of course there is a lot of complaints on the internet about everything. But the boot up time for Clojure itself on JVM, it's pretty slow. Obviously you can't make quick scripts with it. But Planck is, as you say, at the Planck speed, so it's super fast.
Yeah.
So can you use it to make scripts?
So first
how
of all,
would that work?
Yeah, one thing I would make a comment on is I think a lot of us probably think Clojure is slow to start up because of the length of time it takes line to start up when you start up the line REPL. But if you actually, so I of course I compared the Clojure REPL to Planck's startup speed, and Planck's about twice as fast as a Clojure REPL, but they're both really fast. I think, for example, it of course depends on the machine you're on, but the Clojure REPL would start up in say half a second, whereas Planck only goes maybe at a quarter of a second. And Planck is playing this trick on you though, and the way it makes it look faster is when you type Planck, it immediately shows the prompt. It doesn't actually wait until the entire Clojure script engine is up and running. It's that first prompt that you see, the CLJS user, is hard coded in native code. So and that's the trick. So
you're faking it till you're making it.
Yes, it's all a matter of perception, right? So that's
of course.
When you and in fact when you start up Planck, you can actually start typing, and by the time you as a human have finished typing your first form, Planck's going to be finished, starting up. But that trick does not work when you're writing a script, right? Because you're gonna like execute a script, and there's no, you're not typing in forms at that point. The script has got to run. So to answer your question, you can use Planck and you can make scripts that run in about a quarter of a second. If
but in the scripts though, can I use the whole Node.js libraries? Is there any integration with them?
So that's interesting. So Planck is based on JavaScript core. And so it basically, if you kind of look at what Planck really is, it's a bunch of native code that interfaces with the operating system for various things. So like if you use, Planck has like a shell capability, so it'll use NS task. It's an Objective-C way to launch a task. So really Planck is a bunch of glue to hook you into various things, and people are adding new things to it. Eric Assum is working on adding sockets to it. He recently added HTTP support. So it's just a matter of kind of taking the native stuff that exists and then surfacing it, if you will, as Java or JavaScript functions that can then be exposed as Clojure script functions in Planck. But then there is this whole Node thing, and so Planck is not based on Node. Planck's based on JavaScript core, but Ramzi Nasser has been working on a Node-based version, kind of an equivalent. It does more things, but it's also part of it is it can be a REPL. So you can, and he does the very same trick where you start it up and it shows you the prompt right away.
But with the Node one, does that mean you can run it on other platforms as well?
Yep, you can. Yep. As a matter of fact, one thing that's kind of interesting is a lot of the stuff that it takes to create a bootstrapped ClojureScript REPL. If you can imagine, it's like a lot of common code that you would imagine being written over and over again. So that was all factored out. Andrea Ricciardi and the Replum effort. He basically took a lot of Plonk and a lot of the stuff that Joel Martin did initially with making the stuff work in Bootstrap mode, and made a library called Replum that anyone can use to make a Bootstrap REPL. So I then turned around and used that to make one that works on Node, and that one is portable. It runs in different places, but I haven't put a lot of effort into it to make it nice. And Ramsey actually started using the same stuff. So
okay,
I don't know if that answers your question.
Yeah, of course, and
more than answers it.
Yeah.
Rambling on and on.
Actually, I think 2-3 months ago, I was playing with the Lego NXT brick,
the Mindstorms thing. Yeah,
Mindstorms thing with the latest one, and there is a different kind of core that you can use on top of it, and you can install that one, and it comes with a Node.js on top of it.
Oh wow!
And I was able to write ClojureScript and then hook into the Lego NXT thing. That was pretty cool, actually.
I
think I know Anna Polishka.
Yep.
If I'm pronouncing correctly. Yeah. I think she was also trying the same stuff as well, and she's also. I see her tweets.
I took her stuff as well, and my son has one of those, and
cool.
I got him to give me permission to reformat it so that we could use Anna's stuff on it, and it worked. It was cool. Yeah.
Yeah, I think that's what I was doing as well. I just initially I was using Legos. It was a Java-based operating system on top of Lego, where it was super painful to load.
Yeah.
And I had the NXT2 brick, and that was even crappier. Anyway, let's not make it a Lego podcast, but that's something for the guys who are listening. You can run ClojureScript on Node.js on Lego thing and do cool stuff with it.
Indeed.
Well, I think the whole point about ClojureScript at the very beginning was, if I remember rightly, it was Clojure rocks and JavaScript reaches. So I think that was the tagline of Rich at the beginning. So of course now wherever Node goes, ClojureScript can follow. So yeah, awesome.
Okay,
all right.
I think
do you think he's got the job?
I think so.
Yeah. Okay. I'm afraid it's got zero salary though.
Oh, okay.
But you have amazing fame as an open source developer.
But do carry on, and also do everything we ask.
Okay.
Very quickly.
Of course.
But just for the people who are listening in, if you're using Mac, if you're using iOS, I'd really recommend checking out Replete and Plunk and play with it, and hopefully contribute to stuff that is on GitHub. I think Mike has been doing a lot of work and helping us in putting ClojureScript onto these platforms. So thanks, Mike. And of course, you can hang around and let us know if we want to continue with some other topics as well, not just Plunk and Replete in this podcast, because we started with REPLs, and the next obvious thing is that you have a REPL and you want to discuss like what kind of IDEs you use in conjunction, so to speak. And I know there is a lot of IDEs, like a big contention point in the community. Everybody has their own favorites, and obviously I'm one of those people who uses Emacs. So Emacs has
Why is that obvious, by the way?
Because of the way I keep bringing it up every other time whenever I speak editor, and there is only one true editor, and that's just basically Emacs. Well, anyway, so I think one of the major
because you're a real programmer.
I don't want to degrade any other editors though, but they're not real editors. Of course, these days everything is web-based things, and that can't even load 2 megabyte files, and it just crashes all the time. But anyway, so Emacs has been one of the editors for the central Lisp development. It's basically Lisp, of course, with a tiny C core. Probably, as Mike was pointing out, there is a tiny Objective-C core in Plunk, and the rest of it is ClojureScript, I hope. Something like that. So Emacs is built in Lisp, And obviously, there is initially there were some efforts around bringing Clojure to Emacs in different ways. There is Clojure mode, and there is a lot of different kind of packages. But then I hope I'm pronouncing his name correctly, Bozidar Batsov, I think. So he came in, and he's the god of Emacs right now, for at least for the Clojure development. And
he makes great presentations, by the way.
Yeah,
I love this guy's presentations. I'm not a user of his code, but I do love his presentations.
Exactly. I think he's much more into Emacs than I am, though. So I think he brought all the things together, and then there is this community effort called Cider, which is basically Clojure IDE for Emacs, and so that's what I use. And Cider comes with lots of fancy stuff. I mean, there is also CLJ refactor, so all the refactoring things are also available as a package. And I'm not sure how many I don't know if you guys seen Magnar's Emacs Rocks podcasts, and he also made this zombie game in Emacs. I think Zombies versus Parents or something. So he made a live recording of building a ClojureScript game in Emacs, and though his screen casts are amazing. But anyway, so Emacs is one of the nicest things, and of course Emacs is a Cider, obviously, and Cider has this multiple projects in it, multiple packages. So you have the Clojure mode that gives you nice syntax highlighting and everything. That's the standard with every editor. And then you have this REPL connectivity within Emacs, within Cider, that uses nREPL, and it has I think it was before this network REPL put into Clojure 1.8. So there was this effort going on already, and there was some discussions about how the same stuff can be used everywhere as well. So it kind of set a standard, so to speak, in terms of the network REPLs, I believe, at least, for the Clojure and Emacs world. But obviously there are other editors, I think, like Cursive, and last time I was making a joke that, hey, Cider has Cider in it and Cursive has Curse in it, or something like that.
It was a bad joke then. I mean, it doesn't really better, but okay. But yeah, I think what's interesting actually is because I'm a Cursive user, so is Mike as well. So it's 2-1.
Yeah.
But I think what's interesting about Cursive is that it understands the kind of compiler itself understands, and the REPL itself understands the language. That's the big difference, I think, between REPLs that are running in Vim and VI and Emacs and other systems. Whereas with Cursive really understands all of the forms. So when you're looking at the REPL, like in the REPL, you can reformat everything. You can all the syntax highlighting has been working from day one. It's really got a complete understanding of Clojure itself, the syntax, and not just a connection to an external REPL that it can poke and see what the error messages are.
Yeah, of course. I mean, there is probably an Emacs command for that, but I'm not going to say it loud. There is alt-text butterfly or something. Yeah. But one thing
I think, actually, to be perfectly honest, though, I mean, obviously everyone can have their own editors. That's not a problem. Yeah. I think the reason why editors like Cursive are interesting, and the other editors like Atom, which has this ink REPL, is that people sometimes want to come to Clojure and actually just learn Clojure and stick with a kind of editor that they like. Yeah. And the good thing about things like Cursive and Atom and stuff like that is that actually that's possible now. If you're coming from Java or JavaScript or whatever, you can pick up an editor and just essentially have at it with. I mean, actually, do you know that the Microsoft version of their editor? Now, what the hell is it called?
Visual Studio Code.
Is it? Yeah, it's something like that. Visual Code or something. Yeah, Visual Studio Code. Some sort of cut down version of their Visual Studio that Mike was such a big fan of before, apparently. The Visual Studio Community Edition, that's based on Electron, which is this Atom thing. Yeah. And they support Clojure.
Yeah. I think when you're talking about Cursive, I think one of the most interesting use cases for Cursive, for me at least, is mixed code bases, especially when you have Java and then Clojure code base. I don't know if you, and also when you're digging through large code base like Storm, for example, Storm has plenty of Clojure code in it, and then navigating it becomes pretty easy in cursive. So I do that with IntelliJ cursive when I'm navigating large code bases, because you can click around and see the hierarchies and all that stuff. So Storm has some Java code and then Clojure code. Storm, the big data processing thingy, the real-time stream processing stuff. So that's one of the nicest parts about cursive. And also, as you're pointing out, if you're used to Java development and then switching to Clojure development is essentially just installing a plugin, and you know the editor, you're used to it, and there is no. I remember like 3-4 years ago, whenever somebody wants to get into Clojure, the first advice was first learn Emacs, and then that itself, putting people off. And it's a big hill to climb. But these days, with the different kinds of packages, like the Cider's author Bozidar has his own starter package that's very helpful if you want to start with Emacs, and also there is Spacemacs, and those kind of things help. But still, they're built on a lot of historical craft. So you need to understand a different editor completely. But Mike, so we've been, going about cursive versus, this one. So what is your preferred editor?
Oh, I like cursive. I mean, I think I'm a pretty simple human being. To me, Emacs was awesome because it was simpler than VI, way back in the day. And
I don't think so. Come on.
Oh,
I think so. It was WYSIWYG, right?
So, okay, in Emacs, you can just type stuff.
I don't know. I was always a VI guy,
so... Yeah. I guess it was the modes that you have to be in a VI. But anyway, I remember it being that way. But yeah, I use like the normal light mode instead of dark mode, and I'm just very simple. so I'm at home with cursive.
Okay, cool. Yeah. Because now I'm using Spacemacs a lot. So that's basically VI and then Emacs, and then there is a hybrid mode and holy mode, and it's a pretty decent community though. So it's been serving me pretty okay. So,
but just a quick question though: why does Emacs call cursive Clojure an inferior Lisp?
It doesn't, because inferior Lisp is well, it's not Clojure, but initially when there were different kinds of ways to plug in your buffer. Buffer is what they call like the editor window. And then sending the forms to a different process. So there is a process that is started that is inferior to the main process that you're using. So there used to be inferior Lisp initially.
Okay.
And then there was Slime, and then Slime used Swank protocol, and then later, I think when
I was having a joke actually. I mean, I just really meant that you've got on the screen all the time. Inferior Lisp. But that's just an okay Lisp actually,
But you want a superior Lisp.
Exactly.
But you can just rename the buffer,
Good to know. Okay. Actually, I was going to talk to Mike about the stuff, the REPLs that are in Xcode. Because if you're using Swift, the playgrounds and things, I think those guys have some pretty swish things. Or maybe it's just, and actually I remember looking at I think it was on Replete that David Nolan said that there was a scheme REPL that you should imitate.
Yes, yeah.
We should, there's all this kind of stuff out there. But there's a lot of, let's say in the editor land, there's still a lot of potential to make the whole REPL experience a bit more swish, smooth, delightful,
Yeah, one thing I kind of wonder about is just the idea that it's, if you think about things like BASIC, right? You could flip on a computer in the 70s, and BASIC was kind of like amenable to typing into a REPL, right? You could just type in a little simple statement and hit return, and it meant something. And if you think about something like Java, I don't know how the Java REPL is supposed to work. I haven't played with that, but it's like you need to type up enough stuff to mean something in languages like that. So I've only played with the Swift REPL a little bit, and I can't recall what it does with that concept of being able to type in something small enough that actually could be evaluated that is meaningful.
No, it is like that. It really is. Yeah, it's very Clojure-like actually. So you can just write functions, because actually Swift is quite functional. Mm-hmm. You can just write functional forms and just add 2 + 1 and stuff like that, and you'll get a result. Or you can have a for loop, and it's very REPL-like.
Yes, yeah.
I'm curious about the Java 9 REPL though. I haven't tried it yet, but I think it is now ready for developer consumption at least. I think we should. I'll try that out soon. But I remember back in the days there used to be Bean Shell for Java.
Oh yeah.
So you could just play with a smaller version of Java, so to speak, and I, in one of the projects, I embedded it into the Swing application, and then Bean Shell, and that was something that I don't want to recall, but especially moving on to better REPLs these days. Okay, let's see what else. So obviously these REPLs are I think more like development tools, and they're taking some forms and then evaluating them and giving it back. But nowadays there is this better versions. I think the discussion we are moving towards, like you have this Swift playgrounds, and that shows the real time evaluation of your form, and I think in the Clojure side we have now, obviously we have to talk about Figwheel. Figwheel is one of the awesome tools ever. You don't need to refresh, and initially it used to be like, okay, you write code, you compile, wait for this thing, and then reload it or redeploy the whole package and then see the results. Back in the days when I was doing the seam development, JBoss seam and all the other crap. And then,
Jesus.
Yeah. And then there is this hot reloading, and then you have to get some sort of a Java agent to load the classes and all the crap. And then this whole web development, like, okay, I change the code and then I refresh manually and then I see the changes. And even that became a big time-consuming thing apparently. And then the Figwheel came in, and then live reloading. This has been ridiculously different, or even a productivity tool, right? I mean, you just plug in.
For sure, yeah.
You start it, and then every time your code is compiled on the fly, and then you see the results. And even the better thing is, as I was pointing out earlier, before the podcast, obviously, that we have this. I'm now building a line electron application that comes up with a Figwheel support automatically, and then I'm typing the code in, and I see the results immediately, and I also see the error things, and it shows that, okay, I can't load this namespace because there is an error in it. And Figwheel, I think was it Bruce Hauman? I'm very bad with pronouncing names, though.
I think that works. Yeah.
Okay, so I think the effort there is really, really helpful in terms of if you're building code and then you're writing code, you don't need to wait for things to load. But that,
I think the main thing about that is that you can be 15 pages in and some fuck up happens, and then you just make a change to your code, and bam, you can just reload that bit of the application. That's the wonderful thing about it, isn't it?
Yeah.
So you don't have to go all the way back to the beginning again.
Yeah.
That's the really nice thing. But there's a whole class of these things that are hanging around, listening for stuff changing. Figwheel is obviously the poster child of that, but we, in my favorite Hoplon world, we also have that with the Hoplon and Boot. So you have a live coding application as well. So if you make changes to your HLisp or whatever as you're going along, you're changing some CSS on the page or some HTML, bam, it just refreshes it live. You don't need to make any changes. So I think it's worth saying that other tool chains. What do they say in the adverts? Other tool chains do exist, or other tool chains are available. So kudos to Bruce, but also kudos to Alan and to Misha on the Boot and Hoplon side, because they're doing great work over there as well. And it's very, very reactive.
Yeah, and also on the server side. So Mike, you're using a lot of Clojure script. Do you also build Clojure server side applications, or do you use Clojure?
Yeah, I do. Yeah.
Okay. So what kind of tooling that you use there? Do you use I don't know, any Ring middleware like Ring Refresh, or what is your workflow there?
So I think I take more of a basic approach for myself, where I would just I go to the REPL and I type require this namespace with the reload flag.
Okay. Yeah.
But the idea of like Stuart Sierra's component, I think, is pretty compelling. I've started using that recently, and that's kind of nice in the idea of it taking care of tearing down your state and bringing it all back up again.
But to bring up the whole refresh thing, obviously you need to structure an application in such a way that you can reload the state easily, right? Otherwise, it's going to be fairly painful to load. I don't know. Maybe we should compare with the way that you store the state in OM-based applications or Hoplon, for example.
Well, I think definitely the big difference is this is the whether you have a single state or multiple states, how fine-grained your states are. Obviously, it's more fine-grained in Hoplon than traditionally in React.
Yeah.
And the model is very different, actually, I think, between the two things. So one of these days we'll have since we've had a cursive versus cider chat, one of these days we should have a Hoplon versus React chat. Because I see there's a few things doing the rounds there. But I think the whole concept of Hoplon and Boot is basically to say, we're going all the way on Lisp, and we're not going to stop halfway.
Yeah.
Whereas I think the React guys are very practical and saying, well, actually, we get a lot of reach out of, or the OM and the reagent guys are saying, we get a lot of mileage and a lot of reach out of React. We don't get that from JavaScript.
Yeah. Okay, so let's see what other REPLs are available. So right now there is lots of stuff on the web. Obviously, I think the first one was tryclojure.com or something that was running nREPL on the server, and then you're typing forms, and that was the first one.
That brings back good memories.
Or was that someone else? was that Fogus or was that someone else?
Fogus did Chimera, right?
Yeah.
Chimera. Yeah, that's right. Yeah.
But this was even before that, I think, Tryclojure. Maybe it was probably Ryan or somebody. I don't remember. I apologize. I'll look it up next time and we'll give you the proper attribution. But I think the latest amazing thing that we have seen is clips, right? In my opinion, it is possible because of ClojureScript in ClojureScript.
That's true.
Right?
Yeah.
Is that? Yeah.
Yeah. I don't.
So now you have the whole ClojureScript environment available in the browser. So that's.
Yeah. If you look at the way
the whole thing.
If you look at the way Chimera works, it is a ClojureScript REPL in a web page, but it operates by sending forms to a backend server that has Clojure available to compile it. Yeah. But this whole bootstrapping thing allows you to basically have the compiler in the web page with you. And so we could put all the quad core machines that people have these days, and then just use their browser. Yes. Yeah. Farm it out to them.
Exactly.
But what I like about that is the fact that it's just you can, like, I've written some blogs we've all written blogs about Clojure and stuff like that, and the clips guys are basically saying, well, that's all fine. You cut and paste these bits of these gists or these little snippets of Clojure code, but no one can try them. And we're going back to the Brett Victor thing we were talking about before. Brett Victor is all about live code, all about experimenting in the place where you read the thing. If you see some of his his talks about, or his long essays about data being live on the page, this brings us really close to this possibility, I think. Well, not only brings us close to it, it makes it a real possibility, a real option.
Yeah.
So you can, when you're putting your Clojure code out on the web, you can embed it, and people can play with it, people can change it and experiment with it, which is just bloody brilliant,
Yeah, of course. I mean, there was some sort of what I would like to call kind of a prior art, so to speak, I think. So there was CLJS Fiddle, and that was based on JS Fiddle, and you could type in CLJS script. Yeah. And
that just shows you what the JavaScript is, which is nice.
Yeah. So there was experiments, but I think the nice thing about clips is that the whole embeddable concept. You can just put the whole thing in the page and then just make it run immediately without having any other dependencies. And we also had this notebook kind of stuff like Gorilla REPL, and so you can. I think notebooks are like a big rage in the big data world these days, and everybody builds a notebook these days. There is IPython, and there is a Spark notebook, and Jupyter,
Zeppelin.
and all sorts of stuff. Zeppelin, of course, yeah. I think Zeppelin is my favorite thing, though. But there is a Clojure backend for Zeppelin, so I think Zeppelin is pretty cool. But I think Gorilla REPL was the first one in the Clojure world, right? For doing the stuff on the web.
Yeah. And that's also embeddable as well. I mean, you can also put that into into your CMS system or whatever.
Yeah.
So you can publish stuff via what are the Documentum, or what's the Alfresco, that kind of stuff. Yeah, which is amazing.
Yeah. And speaking of the Bruce Hauman stuff, I think DevCards is one of the ways you can have your application state and then keep modifying it. I never used it though. Mike, did you have any experience with dev cards?
No, not directly. One of my coworkers uses it, and let's see, if you try to characterize what is dev cards, it's, Bruce had a podcast recently where he did a good job of explaining it. But it's this idea that you're working on some piece of UI, a piece of UI component, right? And you want to just work on it in isolation. You don't want to have it tangled in with the rest of your application that you're going to be using it in. So you just kind of want to have it off to the side and have some like container to host it in. And you also want to perhaps see simultaneously different variants on that UI component, maybe different, if it's different sizes or different whatever. And you want to like change things and see dynamically or immediately the feedback of what it does to that component. That's my high level understanding of it.
Yeah,
Okay.
I think the main point is that you can, so that's from your perspective, but also I think the idea is that you can then transfer that to other developers. So it's like literate programming model as well. So it's very, it's great documentation because it's the kind of stuff that, we can't be satisfied with Swagger. It's good. Swagger is it's a hell of a lot better than Word. We can all agree on that, But this takes that to the next level, doesn't it? That all of these kind of things, which I think are really fascinating, all these embeddable REPLs, because we moved from like the most fundamental primitive things to now we're really talking about transferable code all over the internet, which is and really using the REPL not only to please ourselves but also to communicate to other people. I think that's really fantastic.
Yeah. Of course, there was other kinds of fun stuff.
We must start doing it one of these days. All three of us are just dilettantes. Obviously, we just never do anything like that. We're just all there to please ourselves. Anyway, right, okay. So I think we're running a bit late, actually. By the way, guys, we're just past the hour time here. So it's just been a great conversation, by the way. So I just want to ask. Maybe a few final questions, Mike. Any final thoughts or tips or anything about REPLs that we haven't covered yet?
One thing I would point out is I think, to me, the whole idea of a REPL is kind of like the basic thing that I mentioned earlier, where it reminds me of being a kid again. When back in the day, you could type something into a computer and make it do something for you immediately. And I think and I hope that so I have a 13-year-old and an 11-year-old, and I kind of hope that the existence of REPLs will help them more readily just hop into programming. Because if you think about it, like if you say, here's a Java IDE, go program, that's a lot of stuff for a kid to, you know what I mean? And
oh God, yeah.
And even like a real Clojure program.
It's a lot for me, to be honest. I really do. I don't know. I think probably all three of us, we probably all do programming REPLs all day.
Yeah, so that's the thought I have, is that it makes it's an entry point for younger kids to say like, I just want to try to evaluate it for them, So my 11-year-old daughter, she knows how to add numbers using Clojure now, because it's so simple to teach that, and she can actually type it into a REPL and get the instant gratification. I think
obviously Replete, I suppose.
Say that again?
Obviously she's using Replete, I suppose, on her phone.
Yeah.
Yeah.
I'm pretty sure that's like an amazing thing. She can just go to the school and then tell, this is what my dad built. I can show you how to define a protocol. Like, wow.
Yeah, I don't think she thinks it's special. She just kind of it's normal to her.
Yeah, that's true.
She's living in the future, that's for sure.
Yeah,
obviously. Yeah. I mean, if she has gone through the pain of building a Spring application, then she would appreciate these things better. I think. But of course, the future generation shouldn't go through the pain.
So what kids these days are getting into is Scratch. Scratch is the main.
Yeah.
It's the
right.
I mean, that's so. There's also Minecraft and the ability to make mods, and that's a whole nother draw for kids. But what I would like is like if there was some kind of bridge from something like Scratch to Clojure. That'd be kind of cool, where like you could almost imagine like a REPL being inside of Scratch. Like if Scratch were written in Common Lisp or whatever, it'd be nice if they would just expose something like that to get kids accustomed to the idea that you can use text to represent code, and
Yeah, I think Timothy Hall or somebody, he had a presentation at Clojure Berlin about making kids programming using Clojure script. I need to look it up.
Okay,
I'll send the link somewhere to you.
Tommy Hall. That Tommy Hall.
Tommy Hall.
Okay.
Yeah.
That Tommy Hall.
Exactly.
Actually, I was there that day.
Yeah.
Yes. And what his point was quite interesting. His point was, you teach these kids like stuff at school, and you teach them in these languages. I can't remember what language it was now, but some language about how to make knitting patterns or how to make, these kind of Isha patterns or whatever.
Yeah.
And then you have specialist languages that you teach the kids how to do it in, and it's all very friendly and it's very easy to use, and it's all based on guys having one arm or two arms, and maybe you can compose them together and do all the for loops and this kind of crap. That's all great, but then the problem is, once you've got to the point where you've done your crochet pattern or you've done your Asia drawing, then where do you go next? You kind of don't go anywhere. You're screwed, because those are just all like educational languages. They're not actually general purpose languages. Anyway, maybe we can come on to what, because that leads us on to the fun part, because of course you're right, we want to get kids involved. And I know Sam Aaron, for instance, his whole thing is to try and make Clojure acceptable to children via music, with this whole overtone stuff, and then the on the Raspberry
Sonic
Pi
Pi
as well, and Sonic Pi, yes, exactly.
Yeah.
And I was actually, he did a presentation at that same Clojure actually, and he's often at the conferences putting using the REPL to play music, and he was telling me that he was telling everyone. But I felt like he was talking just to me. But he was telling everyone that he was like doing a party or something, and he was coding it all in, and of course the people see his text that he's typing, and then listen to the music. And some guy comes up to him and says, "Oh yeah, that's a really great special effects. You got all those like the Matrix type coding up there." He says, "No, I'm coding it. That's how it's making the music. That's what's happening." And so that stuff is great, and that's the sort of thing that I think you can give to kids and let them just have fun with,
Yeah. Anyway, I think we're running through. I think we're running out of time. So I'd like to wrap up. And thanks a lot, Mike, for joining us. And so where can people find you and open pull requests to you for Plank and other stuff?
I think M Fikes or Mike Fikes. I don't have any special avatar or name. So if you're looking for me, just type in my name and you'll find
easy.
Yeah, I'm that kind of a guy.
Yeah. Because for me, it's always been, especially if you hang out on IRC back in the days and you remember by their IRC names.
Yeah.
And then there was never real names. And I still don't remember the Leiningen guy's name. I keep calling him Technomancy because that's what I know.
Yeah.
I'm just stuck with it. And as you can see, that Timothy Hall, that Tommy Hall, I remember his Twitter avatar, and that's weird looking O'Reilly creature. So it's very difficult to put faces there. So, but yeah. So we can find you on Slack, obviously. I think you hang out on Clojure Ians on Slack?
Yes, I do, yeah. Yep. And I'm on Twitter as well. And I don't remember my IDs, but it's always Mike Fikes or whatever, the simplest possible, yeah.
We'll put links to your projects in. Yeah. So what is going to come up next time? So next time, I think we are planning to discuss one of the famous features of Clojure, which is essentially the data types or the persistence collections. So we'll dig deeper into the core data structures that we have in Clojure, and then how they're built and what their features are and which one you need to pick when, and obviously a bit of discussion about maps and records and structs, etc. So I think we'll get into a bit more into the domain modeling as well. So that's I think the topic for the next time. Is there anything that I missed, Ray?
No, I think that's really good. Oh, well, the only one thing we're going to talk about with the collections is the laziness aspect, because I think that's a very interesting aspect of functional programming. Anyway, like you say, we're pretty much done here now. So let's wrap up. We've got all the show notes, or we'll put all the show notes. By the time you listen to this, they'll all be there on the website defen.audio. defn.audio. We also have the MP3 on SoundCloud, and that pushes the RSS feed through to iTunes, so that's all good. We haven't done all the credits properly in the past, so I want to do that now quickly. So first of all, thanks to you, Mike. It was been a pleasure. It's been a pleasure
thanks for having me
talking
on,
to you, and proud of us. Well, this is quite good for us, and we're 3 shows in. We're getting special guests already, so we feel honoured to have you. Actually, let's be honest.
Of course.
Thank you very much. It's been a real pleasure to talk to you. Fantastic.
Yeah, thanks a lot, Mike, and joining us. And of course, I think we should do some other episode as well. Hopefully, in the future, when you release newer versions of it and you take Plunk further with light speed.
Oh yeah, sounds like a plan.
That'll be awesome.
All right, so one final credit is we should credit Pizzeri for the intro and outro music, which is on his SoundCloud. It's called Melon Hamburger. Thank you very much. Okay, so that's it. Goodbye, everyone. Thanks very much.
Goodbye.